Hello and welcome back to the channel Science Math Engineering. Today we are going to solve the APSC Public Health Engineering Department Mechanical Engineering paper for Assistant Engineer Part 4. So let's get started. Question 76. The unit of Stefan-Boltzmann constant is, the answer is, the Stefan-Boltzmann law. From here we get E is equal to sigma T to the power 4. So sigma would be equal to E divided by T to the power 4. So E is in watt and T watt per meter square. So E is in watt per meter square and T is in Kelvin. So it would be watt per meter square and Kelvin to the power 4. However, that is the SI unit. Now if we convert it to our units, so if we convert meter to centimeter, so we get watt per centimeter square Kelvin to the power 4. So our option is C. So we'll go to the next question. In a heat exchanger, the hot fluid enters with a temperature of 180 degrees centigrade and leaves at 160 degrees centigrade. The cooling fluid enters at 30 degrees centigrade and leaves at 110 degrees centigrade. The capacity ratio of the heat exchanger is, so the answer is C. TH1 is 180 degrees centigrade, TH2 is 160 degrees centigrade, TC1 is 30 degrees centigrade and TC2 is 110 degrees centigrade. Now if we see, the TC2 minus TC1 is 80 degrees centigrade and TH1 minus TH2 is 20 degrees centigrade. And from our heat loss is equal to heat gain equation, we have m dot h into Ch, that is hot fluid mass into specific heat, into TH1 minus TH2, that is the net change in the temperature, net heat loss of the hot fluid, is equal to m dot c into Cc, that is mass of cold fluid and the specific heat of cold fluid, into Tc2 minus Tc1, that is the total heat gain of the cold fluid. So from here we get that m dot h into Ch into 20 is equal to m dot c into Cc into 80. So m dot h Ch is equal to 4 into m dot c Cc. So from here we get m dot h Ch, that is the C, there is what we define as capital C is the maximum because this is greater, so it is the maximum one, and then m dot c Cc is the C mean, that is the smaller one, and our heat capacity ratio is given as E is equal to C mean divided by C max. So it should be equal to 1 by 4. So it is 0.25. So our option A is the correct answer. So we'll go to the next question. For 450 meter head of water, dash shall be used. So the answer is a Pelton wheel should be used. So Pelton wheel, it has a range of 80 meter to 1600 meter, and for Francis turbine it is 10 meter to 300 meter, and for Kaplan turbine it is 2 meter to 270 meter. Okay, so we'll go to the next question. Which one of the following techniques is used to determine allowances in time study? So the answer is work sampling is used to determine allowances in time study. Okay, so this is the problem of work study from industrial management. So we'll go to the next question. In a counterflow heat exchanger, the logarithmic temperature difference between the fluids is dash compared to the parallel flow heat exchanger. So the answer is that in counterflow heat exchanger, the log mean temperature difference between the fluids is greater. So counterflow, we have greater, the cold fluid loses more heat and the hot fluid gets more heat. So it has a greater log mean temperature difference compared to the parallel flow heat exchanger. We'll go to the next question. Spiral gears are used only if the axes of two shafts are non-intersecting, non-parallel, and they are non-perpendicular. We'll go to the next question. Which of the following is not a property of lubricants? High specific heat, high flash point, low pour point, or low oxidation stability. So the answer is, see, a lubricant is required to absorb frictional heat without much rise in temperature. So high specific heat is required. Then the flash point of a oil is the lowest temperature at which sufficient flammable vapor is driven off to flash when brought in contact with the flame. So because means if the temperature rises if it has a low flash point, that means if the temperature rises even a little bit, then there will be sufficient amount of a flammable vapor to ignite a fire. So high flash point is desired then. Okay, for a lubricant. Then pour point is the minimum temperature at which oil is capable of flowing under gravity. So pour point should be low so that our oil flows. However, oxidation stability is the ability to resist oxidation that yields acids, pigmented coating or sludge, and this may corrode the material or provide additional friction. So we require is high oxidation stability. So option D, that is low oxidation stability, is not a property of lubricant that we want. So we'll go to the next question. The velocity of a tool along the tool face is known as, so it is called chip velocity. So we'll go to the next question. A long helical spring having spring stiffness of 12 kN per meter and number of turns 20 breaks into two equal parts. Stiffness of the resultant spring will be, so the answer is, n is equal to 20 and k is 12 kN per meter. We know k is equal to z d to the power 4 divided by 8 d cube n. Here if you see z as z small d and capital D, they are same. So only capital N, then the number of turns changes. So n1 becomes n by 2. So k1 would be equal to twice k, that is 24 kN per meter. So we'll go to the next question. A body is subjected to a tensile stress of 1200 megapascal on a plane and another tensile stress of 600 megapascal on a plane at right angles to the former. It is subjected to shear stress of 400 megapascal on the same plane. The maximum normal stress will be, so what we have is that sigma x we have, sigma y we have, and tau xy we have. So we need sigma 1. So the answer is the sigma x. So the maximum normal stress sigma 1 is equal to sigma x plus sigma y divided by 2 plus root over sigma x minus sigma y by 2 whole square plus tau square xy. So from here you get sigma 1 is equal to 1400 megapascal. So we'll go to the next question. By supercharging of petrol engine, the tendency to knock, so it increases. So what happens is that when air is compressed to a higher pressure by a supercharger turbocharger, the temperature is also increased due to compressive heating. Now this should increase air temperature at the start of the compression stroke, which in turn raises all temperatures in the remaining cycle. This can cause self-ignition and the knocking problems in SI engines in the later part of compression or during combustion is seen in these petrol engines. So we'll go to the next question. TDT diagram indicates time and temperature transformation of, so it is the time and transformation of austenite. So what happens is that austenite, if we do fast cooling, it gets converted to martensite. If we do moderate cooling, it will go to bainite, and if it's slow cooling, it is going to pierlite. So this is the decomposition of austenite. So austenite basically is stable only at a very high temperature. Around above 727 degrees centigrade only austenite is there. After that, it changes to these different forms. However, we can have retained austenite if we do not allow it to transform to any of this by some specific heat treatments. So we'll go to the next question. What is the function of a gudgeon pin? So a gudgeon pin is used to connect the piston to the connecting rod. Okay, so the piston and the connecting rod, in between them there is a small pin that is called a gudgeon pin. Okay, so we'll go to the next question. Ice kept in well insulated thermoflux is an example of, now this is well insulated and so it must be closed. So this is an example of a isolated system. So isolated system means no mass transfer and no heat transfer takes place. So we'll go to the next question. The moment diagram of a cantilever beam subjected to bending moment at the end of the beam will be, so it will be a rectangle. We'll go to the next question. Stiffness is the ability of a material to resist. So the answer is the ability to resist deformation under stress. So we'll go to the next question. The torsional rigidity of a shaft is given by, so the answer is, we know, see, T by J is equal to tau by R is equal to Z theta by L. So from here, Gj is known as torsional rigidity, which is equal to T by theta by L. So it should be T by theta by L. However, from these options, it seems like if the if the theta or T is not defined here as what it is exactly, so it may, if it is torque per length or like theta is the theta per L, then it would be T by theta. Otherwise, none of the choices is the correct answer. So we'll go to the next question. C10 number of diesel fuel is about, so it is about 45 to 55. So we'll go to the next question. Which of the following is chosen as a standard thermometric substance? So the answer is, see, we use different thermometric properties for temperature measurement. Okay, 5 types of thermometers are available. Constant volume gas thermometer, where pressure is the thermometric property. Constant pressure gas thermometer, where volume is the thermometric property. Electric resistance thermometer, where resistance is the thermometric property. Thermocouple, where thermal electromotive force is the thermometric property, and mercury in glass thermometer, when length is the thermometric property. Now, if the temperature of a given system is measured simultaneously with each of the 5 thermometers, it is found that there are considerable differences among the readings. The smallest variation is, however, observed among different gas thermometers. So that is why gas is chosen as a standard thermometric substance. So it is gas. Okay, so we'll go to the next question. Steady flow occurs when? So what is steady flow? Steady flow occurs when properties do not change with time. Okay, it may change with space, but it cannot change with time. So we'll go to the next question. The dimension of the coefficient of dynamic viscosity in mass, length, and time notation system are. So the answer is, see, from Newton's law of the viscosity, tau is equal to mu dv by dy. So from here, we can see the coefficient of mu, that is dynamic viscosity, is kg per meter per second. So it is m L to the power minus 1 and T to the power minus 1. So option B is the correct answer. So we'll go to the next question. The total energy of the universe. So the answer is, it is always constant. However, the total entropy of the universe increases. So we'll go to the next question. Chemical formula of Freon 12 is, so the answer is, it is CCl2F2. So it is difluoromethane. So the other options are, the first the CaClF2 is Freon 22, CClF3 is R13 or Freon 13, and CH3Cl is methyl chloride. And all these chemicals, whatever we are here, these are chlorofluorocarbons, and they are banned in all the countries, and they highly deplete the ozone layer. Okay, so we'll go to the next question. Which of the following pumps is suitable for small discharge and high heads? A. Centrifugal pump, B. Axial flow pump, C. Mixed flow pump, or reciprocating pump. So the answer is, reciprocating pumps are used for small discharge and high heads, and they can be built for as high as 700 bar or even more, and they are used for lifting oils from very deep oil wells. Now, centrifugal pumps are used for high discharge and low head. Axial flow pumps are used to deliver huge quantities of water at comparatively low heads, and they are ideal for irrigation purposes. And mixed flow pumps are used for pumping a medium or high flow rate at a medium delivery head. So we'll go to the next question. The cooling curve formed when a material is solidified due to latent heat of fusion is called, so it is called thermal arrest. So see, during solidification, heat is still lost from the mass of the metal, but release of kinetic energy compensates the heat loss. Now thus the temperature remains constant. The heat release at constant temperature is called latent heat, and the cooling curve, that the constant temperature line formed when a material is solidified due to latent heat of fusion is called point of arrest or thermal arrest. Okay. So with this, we conclude the APSC Public Health Engineering Department Mechanical Engineering paper for Assistant Engineer of 2021 paper part 4. So we will see you with another paper. So thank you for watching. See you in the next one.